Hello, geometers. This is Ms. Backfish, and I'm here to talk about our reasons that we use to determine whether two triangles are congruent if we don't know that they are or know all the sides and all the angles. In other words, I'm here to talk about side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. These are the 5 reasons we can give. They're triangle congruence postulates or theorems. Reasons we can give to be able to say, yes, I know these triangles are congruent because of this, or because of this, or because of this. And if one of these is not true, at least one of them, then I cannot say that two triangles are congruent. Sometimes students will say, how do you know the triangles aren't congruent? It's not that we are looking to find out that they're not. We're not trying to prove they aren't. We're trying to prove they are. And if I have any of these, then I can prove they are. And if I don't have one of these, then it's just that I can't prove they are. All right, so let's look. This is mostly just practice using these triangle congruence theorems and postulates. And first thing I want to point out to you is, for any of these, you have to have 1, 2, 3 pieces of information. 1, 2, 3, 1, 2, 3, 1, 2, 3. So where's the 3? With hypotenuse leg, your third piece of information is the fact that you have right angles, because hypotenuse leg is the one that only works for a right triangle. Now, let me be careful about that. I'm not saying you always use this for a right triangle. All of these can work for a right triangle, but these 4 are the only ones that can work for a non-right triangle. This one can only be used on a right triangle because only a right triangle has a hypotenuse. All right, so let's just jump right into these. First thing I'm going to look at is what's marked. So on my first one, this says state if the two triangles are congruent. If they are, state how you know. And I just made up this little cute worksheet to practice identifying when are triangles congruent and how do I know. So I see these little marks that tell me that this pair of sides is congruent. So I have a pair of congruent sides. All right, then I see these little marks that tell me this pair of angles is congruent. So I have a pair of congruent angles. So I have an S and I have an A. I didn't want to write them right next to each other because I don't want to imply anything about the order of the letters here yet. Okay, so I have an S and an A. That's not enough information. That's 2 pieces of information. So I need something else. Now, sometimes there are other things that I know even though they're not marked. And if that's the case, I need to recognize those things and I also need to mark them. So in this particular figure, I do have a pair of vertical angles. I have this angle and this angle. I've got a pair of vertical angles. Remember that anytime you have 2 intersecting lines, in other words, 2 lines or segments, I'm not tracing that very well, but that make like a letter X, boom, vertical angles right here. So that's the other piece of information that I already know without having to have it marked for me. So I can mark that, vertical angles. Well, now I have another A. So if you have 2 A's, 1 S, looking over here, there are 2 possibilities. The good news is with 2 A's and 1 S, they definitely are congruent. So these triangles are congruent. So I could go ahead and say yes. I just have to decide which reason now, okay? And it's not about the order going around. Sometimes people want to walk around the outside of the triangle and say, well, angle and then side. Don't do that. Look at, is the side in between the 2 angles? Is it the included side or the not included side? And the included side means if I start at one of the angle vertex, the vertex of one of the angles, and I trace to the other vertex of the other angle, did I go across the side? Yes, I did. That is the marked side. And over here is the side that goes between the angles, the marked side? Yes. That's called the included side, the side that goes between the angles. So because the side is between the angles, the S is between the A's, and my reason is ASA, angle, side, angle. All right, let's look at number 2. On this particular one, I already have 3 pieces of information marked. I have a pair of congruent angles, then I have another pair of congruent angles, and then I have a pair of congruent sides. Okay, and again, That's 2 A's, 1 S. So I'm going to look at this and say, all right, I know these triangles are congruent by one of these two reasons. It all depends on whether the side is the one in between the two angles or it's not in between the two angles. And by the way, this is the same as this. The order does not matter. Okay, if the side is not in between the two angles, then it's AAS or SAA, doesn't matter which one. All right, so I'm looking at my two angles. If I go from the vertex of one of them to the vertex of the other one, did I just trace the side that's marked? I did. How about over here? Go from the vertex of one of them, one of the angles, to the vertex of the other angle. Is that the side that's marked? Yes, it is. So that is the included side again. So the S in between the two A's, specifically, this is not random. This is saying my side, my pair of sides that's congruent has to be in between the two pairs of angles that are congruent. So that's good. And it has to be the same on both too. If it was in between on one of the triangles, but not in between on the other, that would be not enough information. That would not be a reason to say these triangles are congruent. All right, looking at number 3. Number 3, I've got a pair of angles. And then I've got another pair of angles, well, right there. And then I've got a third pair of angles. So basically on this one, I know that all of the angle pairs match. I don't know anything about side lengths. Angle, angle, angle is not a reason to be able to say that triangles are congruent. If all the angles are congruent on two triangles, that means they're the same shape, but they're not necessarily the same size. And congruence means same size too. So I would just say, not enough information. I don't know. If you told me something about any of the sides, maybe they're congruent. But right now, I don't know that because I don't have one of these. You have to have one of these to be able to say, yes, these are congruent triangles. All right, over here, number 4, I've got a pair of angles. I've got another pair of angles. Okay, that's 2 pairs of angles. That's 2 pieces of information. Remember, we need 3 pieces of information for each of these. So then the question becomes, is there anything happening here that I already know is true, even though it's not marked? And yes, you've got intersecting lines, so you've got vertical angles. This angle and this angle right here. This one, there they are. Vertical angles are congruent. So this is actually just like this one. I know all 3 pairs of angles, but I don't know a single thing about sides. All of the reasons require knowing something about the sides. There's no angle, angle, angle. So again, not enough info. Number 5. Number 5, I have a pair of sides congruent. I have another pair of sides congruent. Okay, that's 2 pieces of information. That's 2 S's. I'm just going to put S's, just some random S's to point out I've got 2 S's. Is there anything else I know? Because there's nothing else marked. Well, if you have the same side in both triangles, in other words, this segment, this line segment, is in both triangles. So therefore, it has to be the same length in both triangles because it is the same segment. That counts. Sometimes called a shared side, that counts as a pair of congruent sides. We use the reflexive property to say anything is congruent to itself. So that's a good reason to be able to say these two triangles have 3 pairs of congruent sides. And so I can say, yes, side, side, side. Okay. Number 6, this has become a theme on this particular. I just randomly took this one, but what seems to be funny about it is number 6 is going to be just like number 5. Look at how it's like number 5. We have a pair of congruent sides. We have a pair of congruent sides. And we have that side that's in both triangles, so I can count it as a third pair because it's the same size in both triangles. One thing that can help if you struggle to see how the shared sides work sometimes is redrawing the triangles with a little bit of space, like pull it apart. Think about what it looks like if you pull it apart. So it's like I took this and I put some space in the middle. So yes, this side is the same as this side. That's what we have here. They're just right up against each other. So that one would be side, side, side. and it would be yes by side, side, side. Okay? Now, let me point out another thing is, sometimes I'll have students tell me, this is side, angle, side, or angle, side, angle, or something like that. You don't have any information about angles here at all. So you should not be giving a reason over here that has an A in it, because I don't know anything about an angle pair being congruent. So this has to make sense with what we see. All right, number 7. All right, we've got a pair of sides that are congruent. Then we have a pair of angles that is congruent. And then finally, we have another one of those shared sides. So this particular segment is in both triangles, that one I just traced in pink. And so that counts as a pair of congruent sides as well. So I have 2 pairs of sides and 1 angle. So again, I've got 2 S's, I got 1 A, and I'm just randomly writing those letters. And then I look at my reasons. The only one that has 2 S's and an A is right here. So this is a very important decision. I have to decide if it's this or if it's not this, because if it's not this, we don't have enough information. The only way for 2 triangles to be determined congruent when they have 2 pairs of sides and 1 pair of angles congruent is if the A is right in between the 2 S's. It has to be the included angle. It has to be the angle that is in between the 2 sides where the 2 sides meet. So on this triangle over here, for instance, here's a side, here's a side. Is the angle that's marked the one right where they meet? Yes. Over here, here's a side, here's a side. Is the angle the one where they meet? Yes. So it is the included side, the included angle. So because of that reason, this is a yes by SAS. All right, number 8 is a little different. Now let me point out, it's a right triangle. There's a right angle here. Now, that doesn't necessarily mean a whole lot because it just tells me that pair of angles is the same. And one other thing it tells me is that I could potentially use HL. Now, remember what I said earlier, the fact that I see right angles here does not mean it definitely is HL. It means that's one of my options. On all these other triangles I've been doing, HL was not even an option because I didn't have right angles. But on this one, it could be side, angle, side, 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 angle, side, angle, 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 side, or hypotenuse, leg. So let's see what we've got. Okay, I see a pair of right angles, so that counts as an A or as my right angles. I see a pair of sides. The question I would have first is that pair, where on that triangle, where on the right triangle is that pair of sides? And it turns out it's the hypotenuse. Remember that on a right triangle, 2 sides meet at the right angle. The one that doesn't touch the right angle, the one I didn't just trace in pink, that's the hypotenuse. So it's the hypotenuse here. And on this right angle, the 2 sides that meet there are right here. And the one that doesn't touch the right angle is across here. That's the hypotenuse. So I do know that the hypotenuses are congruent. I have to specifically know that to be able to use HL. It can't just randomly be, hey, it's a right triangle, therefore it's HL. No, I have to know that the hypotenuses are congruent, and I have to know one other side. This is for leg, one other side of the triangle. And it turns out I do. I've got a leg that's the same in both triangles, so I could say that side is the same length as itself. So that counts as a pair of congruent sides. So I have hypotenuse, leg, right triangles. That's yes by HL. All right, next up, number 9. We've got a pair of sides marked congruent. There they are. We've got another pair of sides marked congruent. There they are. That's 2 pairs of sides. Is there anything else? If there's nothing else I know, I would have to say that's not enough information. But I do see a pair of vertical angles. So I do have that information, and please don't forget to mark it. So I have 2 S's and an A. Remember, there's no ASS in geometry. There's no ASS, there's no AAA, and there is also no ASS, which would be the same even if you turned it around to make it a nicer word. Okay? Neither of those works. If you have, remember we said if you have two sides, two pairs of sides in one angle, pair of angles, it has to be the one in between. It has to be that or it's not true. All right, it's not congruent. So let's see. Side, side. Is the angle that's marked the one where those two meet? Yes. Over here. Side, side. Is the angle that's marked the one where those two meet? Yes. So it is side angle side. Next up, we have number 10. We have a pair of angles congruent. We have a pair of we have a pair of sides congruent. Keep in mind at any point you can pause this video and try the next one before I start talking about it. That's not enough information. That's 2 pieces of info. I need 3. So I'm looking to see if there's anything else I know here. Is there? Yes, I know I have vertical angles and they will be the same. Okay, so now I have 2 A's. Here's A, and then I have an S. All right, I have 2 pairs of angles, 1 pair of sides. So remember, if you have 2 A's and 1 S, it's going to be one of these. I have to decide if the side is the included side, the one that goes between those 2 angles, or it's not the one that goes between those 2 angles. So I'm going to trace from the vertex of one angle across to the vertex of the other angle. I did not trace the marked side. The marked side is over here. Same thing happens over here. So it's not included over here. It's not the included side. It's not the one in the middle. Over here, when I go between these 2 angles, I'm tracing this side right here, not the one that's marked. So it is the non-included side on both of them. So that's yes by AAS. And that would be fine if you said it backwards. It means the same thing. It's 2 angles and the side that is not in between them. Okay, when we get to number 11, we see 2 triangles that both are right triangles. So again, that means I have 5 options for what my reason could be that they could be congruent. All right. The main thing I'm going to look for is I'm going to look for where on these right triangles, pretty much anytime you look at a triangle, anytime you look at a right triangle, where is the hypotenuse is the first question I ask. So again, think about the 2 legs meet at the right angle. Those are not the hypotenuse. So the hypotenuse is this one over here. And again, the 2 legs are meeting at the right angle. They are not the hypotenuse. Here's the hypotenuse right over here then. So the hypotenuse is the side that does not touch your little right angle symbol. Okay, so we've got the hypotenuses marked as congruent. So I do have H. I've got the H for HL. Okay. Now what else do I know? Well, I know another pair of sides. Well, every other pair of sides in a right triangle is called the leg. So yes, I have HL. Boom. Next up, number 12. I have a pair of angles. I have a pair of sides. That's not enough. There must be something else going on. There is. I have a pair of vertical angles. So I have another pair of angles. So I have first pair of angles. I have a pair of sides. I have a pair of angles. And I have to decide which of these orders that is. And that all depends on whether the side is the one that leads from one angle to the other, one vertex to the other, or if it's not. So let's go over here and look. I'm going to trace my path from one of my marked angles vertex to the other vertex of the other marked angle. So there we go. Was that the side that was marked? No, the side that was marked is over here. So that is the non-included side. So here would be the included side for these 2 angles, the one that goes between the 2 angles. Here is the non-included side. So in both cases, it's not the included side. So it means the S is not right in between the 2 A's. So it's this one. So yes, AAS. All right, now we have a different type of problem from this part on. It says state what additional information is required. Now, recognize that that means there's not enough information. I guarantee there's not enough information. There's not supposed to be enough information. You are being told there's not enough info. What else do we need? What else is required if we knew that the triangles were congruent for the reason given? So for number 13, that's like saying, okay, here are two triangles. If I were to tell you they were congruent by side, 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 look at what you've got so far. You've got, let's see, a pair of sides. You've got another pair of sides. What's missing? Because it's like, all right, I've got a pair of sides. I've got another pair of sides. What's missing? Another pair of sides. Well, there's only one other pair of sides there could be. So the other pair of sides that could possibly be congruent and that we need to be congruent would be right here. This is what we would need for it to be SSS. So I would answer this by saying MK, segment MK, needs to be congruent to segment CE or EC. I'm not terribly picky on that. For those to be congruent. Being particular about order, it would probably be EC, but this would be a fine answer in my book. Okay? So I'm basically filling in the blanks. That's what I, as the student, am doing on this problem. I am filling in the blank in terms of if I were making this for a student, what else would I have to tell them if I wanted them to think it was SSS? So, okay, over here, if I need this to be HL, let's see what I've got so far. Well, I do have right angles, and you have to have right angles for HL. So we have to know we have right triangles to have HL because that's part of what makes it HL. Then I've got this shared side. Segment SR is in both triangles. Okay, now this might be a good one to draw separately just to kind of show how this works out a little bit more clearly. And I'm sorry that my drawing is not perfect here. It's not even close. But it doesn't have to be. We're just going to mark it R. Here's R, T, S. Okay, so SR is in both triangles. So that counts as a pair of congruent sides. Now remember, we said when we look at a right triangle, the first thing we want to think about is where's the hypotenuse? The two sides that meet at the right angle are not the hypotenuse. So here is the hypotenuse. Two sides that meet at the right angle are not the hypotenuse. So here is the hypotenuse. Okay. So if I want it to be HL, I have to know that the hypotenuses are congruent, and I don't know that right now. I do have legs that are congruent. SR is a pair of legs, basically. But I need to know that KR is congruent to TS. So that's what I would answer. I need KR to be congruent to TS for these to be congruent by hypotenuse leg. All right, number 15. Angle, angle, side. All right, I see a pair of angles, so I've got one pair of angles. I do see a side that's in both triangles, so that's a side. For it to be angle, angle, side, remember it has to be two angles and the non-included side. I only have one angle right now, so I need another angle. And it has to be the angle that this does not go between them. In other words, this is not the included side. Well, that's good because it's not going to be, because this is way over here. So I could actually do either pair of angles in this case. I could either say, well, this angle and this angle is congruent. And that I would give as my answer, I would say angle BHI is congruent to angle GIH. And I put that in the wrong order, sorry, GIH. That's what that says, believe it or not. Or the alternate plan here could be, I'm just going to go ahead and write GIH there so it's really important, really clear. All right, the other thing I could have said is I could have said this angle right here and this angle right here. So I could have said BIH is congruent to GHI. Ugh. There we go. That's the other option. So either of those pairs of angles would have been fine. You only need one of them. Next up, side, angle, side. All right, I see a pair of sides. Great. That's all I see. But don't forget, vertical angles are always congruent. So I also see a pair of angles that are congruent. And I need one more pair of sides because I have an S, I have an A. That's what I've got so far. What I don't have is the other S. I don't have another pair of sides. So it has to be the pair of sides where the angle, remember, is right in between those two sides. Those two sides need to meet at my marked angle here. So it has to be the included angle, which means, there you go, it has to be this side. And over here, it has to be this side. So it's going to have to be WV and RV. So I'm going to say WV is congruent to RV. I started getting colorful here. We are on the home stretch. We got 4 more problems to go. Number 17. Again, don't forget, you can pause and try one and then see if I get the same thing as you. Side, side, side. Well, I see one pair of sides, another pair of sides. Seems like all I'm missing is the last pair of sides. So I'm going to say XZ is congruent to QS. And that's my answer. XZ is congruent to QS. Number 18, angle, side, angle. All right, I have a pair of angles. Those are congruent. I have a side PQ as a segment that is in both triangles. And again, if it helps you, draw these separated out. This is not perfect, sorry. I said that last time and I was way off perfect. I'm still way off perfect. This is even worse. I don't know how I'm doing that, sorry. It is kind of a bad angle. But we can still use the drawing I just made. Why not? The point is that QP is in both triangles. So that counts as a pair of congruent sides. And then we have this. If we need it to be angle, side, angle, remember that specifically needs to be the included side. It has to be the side that is marked, which in this case is PQ. It has to be the one that goes between the two angles. Same thing here. So it has to be the angle up here at the other end of that side on both triangles. So I'm going to say, so this angle and this angle, so that would be angle RPQ is congruent to angle KPQ. RPQ, KPQ. Remember, the middle letter has to be the vertex. There is my answer. Number 19, angle, side, angle. Well, I see 2 pairs of angles. That's great. So it looks like all I'm missing is a side. And it needs to be the side that goes in between the 2 angles, the included side. So that would be this side here, and it would be this side here. So I need to know MN is congruent to TS in order to use angle, side, angle on this particular triangle pair. Last but not least, side, angle, side. Here's one pair of sides. Here's that shared pair of sides. That's a second pair of sides. All I'm missing is an angle. And it needs to be the angle where the 2 sides meet in both triangles. So I see the 2 sides meeting right up there. That is not angle V. Do not call that angle V, because angle V could mean a lot of things. You have to be specific. That's angle WVU. U is congruent to. In the other triangle, it also has to be the included angle. So over here, it has to be QVU, meaning this angle and this angle. And that is it. I hope this has really helped you. Let me know. Make your comments. Let me know what else I can help with. Thanks for watching.